Hello, in this video I'm going to solve problems in homework number 7, question 1. If in the following figure L1 is parallel to L2, then we want to find the size of angle X. So here you see that line L1 and line L2 are said to be parallel, and then I have a line that cuts L1 at an angle 50 degrees, and I have the second line cutting L2 at an angle 100 degrees. We are supposed to find the size of this angle X. The first thing that you will do is to draw a line that is parallel to L1 and L2 and passes through this point. You will see how this will help us. So let me just do that. So I draw this line, the red line, parallel to L1 and L2. So that's L1, and this line that I draw, and I call it L, is parallel to also L2. So these three lines are parallel. Okay, so then you see immediately that because these two lines are parallel and this is now transversal, this acute angle and that acute angle are the same. Because in the lesson we learned that if we have two parallel lines and a transversal, we have cutting them, all acute angles constructed on these two lines and all obtuse angles constructed on these two lines are correspondingly equal. Okay, so if this one is 50, this one is also 50 degrees. So let me write here 50 degrees. And exactly the same way, I would say now this line is parallel to this line and this one is transversal. Okay, so what does it mean? This means that this acute angle and this acute angle are the same. Okay, or for example, as we learned in the lesson, you can construct a Z-shape thing here because this one is parallel to this one. This angle is supposed to be equal to this angle. But what is this angle? Because the whole angle is supposed to be 180 and this part is 100, this will be 80 degrees. And if this is 80 degrees, this part becomes 80 degrees. And now I am looking for the whole X. The whole X is just 50 degrees plus 80 degrees, which is 130 degrees. And then because the degree sign is already typed, so what you just need to type here is the number 130. Okay, question number 2. If in the following figure L1 is parallel to L2, we want to know what is X plus Y plus Z. Okay, the first thing that comes to mind is to calculate X, because here we know that the total sum of these three angles should supposed to be 180 degrees, and by drawing this angle in this form, they are telling us this is 90 degrees. So the first thing that I will do, I would write X degrees plus 90 degrees plus 2x degrees is 180 degrees. X degrees plus 2x degrees becomes simply 3x degrees, and I move 90 to the other side, make it negative. It becomes minus 90 degrees. So 3x degrees becomes equal to 90 degrees. I divide both sides by 3, so x degrees becomes 30 degrees. But I want to find the pure number x. You see here x is without the degree sign. If x degrees is 30 degrees, x itself as a pure number is just 30. So this is my x. Okay? Now I go and find y. How? I see that this line is said to be parallel to this line, and I see that this line is transversal. So this acute angle constructed on the top line and this acute angle constructed on the bottom line, they have to be the same. This is one way. Another way, you can immediately recognize your Z shape here. Yes, because these two are parallel, these two angles should be the same. So in any way, we understand that 2y degrees is supposed to be equal to 2x degrees. So 2y degrees is equal to x degrees. It means 2y, by just dropping the degree sign, is x, but we just got what x is. X is 30 and I want y, so I divide both sides by 2. So y as a pure number is just 15. And then immediately you can find z. Why? Because again, we know that the sum of these two angles should be 180 degrees. So in other words, z degrees plus 2y degrees is 180 degrees. I drop the degree sign, so z plus 2y is 180, but I just got y to be 15, so 2y becomes 30 is equal to 180, and the z that I am looking for is 150 by moving 30 to the other side and make it negative. And now the question mark is x plus y plus z. I just add these numbers. X is 30, y is 15, and z is 150. So if I add them, it becomes 195. And 195 is the number that I have to type here. Okay, question number 3. So here in the following figure, we want to find the sum of x, y, and z. But be careful here. They have put one arrow here on these two lines, meaning that these lines are parallel. But they have put two arrows here and two arrows there, meaning that these two lines are also parallel. Okay, so we want to find these numbers x, y, and z. The first thing comes to mind is to start from here, because we know that the sum of these two angles should be 180. So I would say that 2y degrees plus 106 degrees is supposed to be 180 degrees. So 2y degrees is equal to, I move 106 to the other side, and then 2y degrees becomes, this is 106, it becomes 74 degrees. I divide by 2, so y degrees becomes 37 degrees, but I drop the degree signs because I want a pure number, so y becomes 37. Okay, so y is found, and I hope that you immediately understand that x is equal to 2y. Why? Because we know that these two lines are parallel, and this line is cutting both of them, so it is called transversal. So it means all acute angles constructed on these two lines should be the same. So x is an acute angle, 2y is also an acute angle, so they have to be equal. So this means that x degrees is equal to 2y degrees. I drop the degree signs, so x becomes 2y, but y is 37. If I multiply it by 2, it becomes 74. Yes, so what I did, I took this 37 and put it here, multiplied it by 2, I got 74. And now we change the reasoning from, so now I go to use these parallelness of these two lines is, the parallelness of these two lines and giving the role of transversal to this line. Okay, so these two lines are now parallel and this line is transversal. So this means all obtuse angles are also the same. So this means that this angle that you have here is equal to this angle that you have here. Okay? And this angle you can find because you already found x, so you can easily find this angle. And this angle is exactly equal to what you have. Okay, so for example, if I write this angle, if I call this angle alpha, I know that alpha plus x, so let me call it alpha degrees. So this means that alpha degrees plus x degrees is 180 degrees. Yes. And then what do I have? I have x is 74. So alpha degrees becomes 106 degrees. So this means alpha is 106, but alpha is equal to 4z plus 6, so 4z plus 6 is 106, so this means 4z is 100, so then it means z is 25. Yes? But the question mark is asking about the sum of these three angles, so it becomes 37 plus 74, so far 111, and I have also a 25, so it becomes 136. So the answer that I have to type here is 136. Okay, question number 4. In the following figure, we want to find the value of y. Okay, so again, by putting this arrow here and there, they are telling us that these two lines are parallel. And now you see that this line plays the role of the transversal. So this means this acute angle constructed on the top line and this acute angle constructed on the bottom line, they have to be the same. Or you can consider your Z shape. Of course, this is not a complete Z shape, but you understand what I mean. This looks like a Z and these are parallel. So again, this angle should be equal to this angle. Anyways, we understand that 3x degrees is supposed to be 5x minus 20 degrees. But dropping the degree signs, I can write this. And this is a very simple equation. I move 5x to the left, make it negative. Minus 20 is on the right side. And 3x minus 5x is minus 2x is equal to minus 20. I divide by minus 2. X becomes 10. So the pure number x is 10. But of course, x is not wanted directly in the problem. But it will be useful for doing that, for finding y. The other observation is that I see that this is a triangle. Yes, and I know that in any triangle, the sum of all interior angles is supposed to be 180. And because I already found x, this will help me to find y, which is wanted in the problem. So what I would write, I would say that 2y degrees, I'm adding the angles, the interior angles, 4y degrees plus 5x minus 20 degrees, which are the interior angles of my triangle, they have to add up to 180 degrees. 2y degrees plus 4y degrees is 6y degrees plus 5x, and x is 10. So let me put this there. 5 times 10 minus 20 degrees is 180 degrees. This becomes 6y degrees. But this number, 5 times 10, 50 minus 20, 30. So it is 30 degrees. Okay, and I move 30 degrees to the other side, so it becomes 150 degrees. I divide by 6, y degrees becomes 25 degrees. So the pure number y is just 25. So what we have to type there is just simply 25. Okay, question number 5. Consider the following figure. If angle CAD is 65 degrees. So where is angle CAD? CAD. So this is angle CAD, which is 65. So if you don't mind, let me write the information on the figure. This is very helpful if you want to solve these type of problems. Always do that. And the angle CED is 70 degrees. So CED. Oh, sorry. CED, it doesn't matter, of course. This angle is 70 degrees, so let me also write it there. So this angle is 70 degrees. So let me put double dash here. Okay, and then CD, in the problem, this is mentioned, CD is the angle bisector of angle ACE. ACE is this angle. And they are telling you that CD is the angle bisector. So this means that this angle and that angle should be equal in size. Okay, whenever this happens and you are solving about angles, it would be good to give them names. But because this is angle bisector, if I call this angle theta, I am also allowed to call this angle theta. Of course, you can give them different names, but don't do that because then the number of unknowns increases. So if you know two angles are equal, give them the same names. Okay, now my goal is to find this angle x. Okay, so the first thing that I observe is that this angle x is an exterior angle for triangle CAD. Why is that? Because if you look at this triangle, this angle is an interior angle, this angle is an interior angle, this angle is an interior angle. If I extend this side on the right, this angle that is outside my triangle here is an exterior angle. And we learned during the lesson the size of an exterior angle is equal to the sum of the sizes of the interior angles that are not adjacent to the exterior angle. So what do I mean by that? This exterior angle is adjacent to this interior angle. Forget about this. There are two more left, this one and that one. This exterior angle x is the sum of these two. So we know that x is equal to 65 degrees plus theta. Okay. Of course, in the exam, you have to explain that I write this relation because x is the exterior angle of this triangle. But because I talked about that orally here, I didn't write it down. Okay, so that is one observation. But of course, in order to use this to find x, I need to know theta. Then it is not hard to consider this bigger triangle here, because we know that the sum of all interior angles, which is 65 degrees, 70 degrees, and the whole angle here, which is 2 theta, it should be 180 degrees. And it will help me to find theta. When I have theta, I put it here in this formula and I find my x. So let us do that. Okay, so I would say that as I mentioned, 2 theta plus 65 degrees plus 70 degrees, this should be 180 degrees. So 2 theta, 65 plus 170 is 135 degrees is equal to 180 degrees. So 2 theta is equal to what? 180 degrees minus 135 degrees, which is 45 degrees. So this means theta is 45 divided by 2, which is 22.5 degrees. This is your theta. Okay, now I will take this theta and put it here, and then I find x. So what is x? X is equal to 65 degrees plus 22.5 degrees, which is 87.5 degrees. So x is 87.5 degrees. Yes, but again, the degree sign is typed here. So what you need to type is just simply 87, or 0.5. Okay, finally, the last question, number 6. Consider the following figure. If AB is equal to AC, so this means that the bigger triangle is an isosceles triangle because they are telling us AB and AC are equal. They are also telling us that AD and AE are equal. So this means AD from A to D and from A to E are also equal. Yes? So this means that this triangle is also an isosceles triangle. And then you are supposed to find angle X. Okay, so in these kinds of problems, if you don't mind, let me make the picture bigger for you a little bit. Yes? So, what we do, this is very helpful. You are looking for angles, try to give them names. Try to give the name, the angles in the problem names. But if you know two angles are equal, give them the same names. For example, because the bigger triangle is an isosceles triangle, so I know this angle should be equal to this angle. So for example, if I call this angle alpha, I am allowed to call this angle also alpha. But I know that this triangle, that I know that this length is also equal to this length. So this means that this triangle is an isosceles triangle, so these two angles are also the same. So if I call this beta, for example, I am allowed to call this one beta as well. So let us do that. So let me call this beta, and let me call this beta again. Okay, so now let us go to the original size. Now what you can see is that this angle, I want to use the theorem of exterior angles 2 times here in a very nice way. You'll see how it will facilitate to solve the problem. So here, this angle that you can see here is an exterior angle to this very small triangle here. Yes, so this angle is an exterior angle of this triangle. So beta is the sum of 2 interior angles not adjacent to beta. So one of them is alpha, one of them is x. So I can immediately write that beta is alpha plus x. Again, if it is an exam, you have to explain what I said to you orally now. On the other hand, if you look here, the whole angle that you can see here is an exterior angle of this triangle, yes? So you see that this angle is sitting outside the triangle by extending this line. So this angle that you see here is the sum of these two angles. So sorry, this angle is the sum of these two angles. But this angle itself consists of 2 parts, beta and x. So in total, this angle is beta plus x. So I understand that beta plus x is equal to 30 degrees plus alpha. Okay, but now what I will do, I will take this beta and put it here. So instead of this beta, I can put alpha plus x. So it becomes alpha plus x. But I also have another extra x there. It becomes plus x. And on the right hand side, I have 30 degrees plus alpha. And now the good news is that this alpha, when I move it to the other side, it becomes minus alpha and will cancel the other alpha. And these two just can combine to 2x. So then it means 2x is equal to 30 degrees. I am looking for x, so I divide by 2. So it is 15 degrees. You see, it was a very nice way of using the notion of exterior angles 2 times in this problem. And again, the degree sign is typed there. So the number that you just need to type here is just 15. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.